Welcome back. We are still in lesson 3, Toss the Cup, where we are talking about experimental probability. Let's get started. Examine the spinner shown. List the sample space. Now, I'm not going to do this for you or with you, but I do want you to complete questions 1, 2, and 3 on your own. First, now that we know what a sample space is, and we can answer questions about probability. So, question number 2 says, can you use the sample space to determine the probabilities of a spinner landing on each symbol? Why or why not? And number 3 says, on which symbol does the spinner have the highest chance of landing, and which symbol does the spinner have the lowest chance of landing? Okay, at this time, I want you to pause here and you're answering one, two, and 3. Set a timer for about 2 minutes. 2 minutes max. Answer 1, 2, and 3. Pause here. Alrighty, your 2 minutes are up. Let's compare answers. So the sample space that you should have gotten were the sun, smiley, and star in no particular order. For number 2, can you use the sample space to determine the probabilities? Why or why not? And I had put no because each symbol takes up a different amount of space, right? And also, do you know how much each space or how much space each symbol takes up of the spinner? No, there are no percentages, there are no fractions, there is no specific number tied to these spaces. And number 3, it says on which symbols does the spinner have the highest chance of landing? The highest chance is obviously the star because it takes up almost half of that spinner. And the sun has the lowest chance of being selected because it takes up the least amount of space. Now, you also could have put the smiley face and the sun have the lowest chance because it does say symbols, and those two have the smallest chance because they are both smaller than the star. Alrighty, you should have those answers down. If you don't yet, take a couple seconds, look at my notes, and get those down. But we are moving on. Number 4 says, predict the probability of a spinner landing on each symbol. So now, being that there are no numbers, fractions, or percentages tied to these spaces, we're just going to make a prediction. Now, there is no right or wrong way to predict. We're just going to mark this up and see what numbers we get. So I'm going to start with the star. So I know that if I were to draw a line across here, that'd be about half of that spinner. That'd be about 50%. But then there's this tiny little sliver here. So I know that the star is probably going to be a little bit less than 50%. So my prediction is going to be about 50%. I know is about 5 out of 10 or 50 out of 100. So I'm going to put that exactly 50 out of 100 just to make it. Oh, wait, hold on. Sorry, back up. Sorry, I said slightly less than 50%. So that's about 45%. So 45 out of 100, 45%. Or if I were to take this a little further and simplify, that would also give me 9 out of 20. Now, you can make your own predictions for the star and the smiley, but I'm going to kind of give you an idea of how you can figure this out if you'd like. So we said this was about 45%. And remember, all 3 of these have to add up to be what number? 100%, because all probabilities add up to be 100. So if I know that's about 45%, I'm just going to move on to this sun because I see that this is about a quarter of this circle. So I'm going to estimate about 25%. And then whatever's left over, I'm going to guess is my smiley face. So 45, 25, that gives me about 30% left over. So now I'm going to just translate these numbers into question number 4. So our smiley was about 30 out of 100, which was 30%. And our sun was about 25 out of 100, which we know is 25%. And to take it up even further, our fraction form, that is about 1/4. And 30 out of 100 is 3/10. Alrighty, go ahead and get those numbers down because now we are about to discuss. So moving forward, question number 5. It says, Jonah and Melanie make the following predictions for the spinner landing on each symbol. Explain why each student is incorrect. So notice it already tells you Melanie is incorrect. Jonah is incorrect. But what I want you to do is discuss why. And when you're discussing why, make sure to annotate and mark up Jonah and Melanie's answers so that you can solidify and explain why each student is incorrect. And put your explanation somewhere down here underneath their work. And then I also want you to, in this time that we have, answer question number 6. It says, is there a way to determine the exact probabilities of landing on each of the shapes? And you're going to explain your reasoning. So at this point, you're going to pause here. You're going to answer questions 5 and 6 on your own or with a partner. Pause here, take about 2 minutes max. So 2 minutes max, 5 and 6, pause here. Alrighty, I hope 2 minutes was enough time to work. If not, make sure you're taking these notes as we go over 5 and 6. So now let's look at Jonah and Melanie's work. So Jonah is incorrect because the sun and the smiley do not have the same chance of being selected. As we saw on the spinner, the smiley has a slightly larger area than the sun. And Melanie is incorrect because all 3 symbols do not have the same chance of being selected. They are all different sizes. And number 6 says, is there a way to determine the exact probability? Well, no, because there are no values assigned to any of the spaces on the spinner. So we just have to make our best guess as far as what the probabilities might be. Alrighty, go ahead and finish up putting that into your own words, and we are moving on. So, question 7, it says, let's determine the experimental probability. Remember, we learned that in the last activity. It is what actually happens when conducting an experiment. Determine the experimental probability of a spinner landing on each of the symbols. Use a paperclip as the arrow part of the spinner. Place a pencil through the point, blah, blah, blah. Okay, moving forward, because unfortunately I don't have those manipulatives to give you through the computer screen. So let's get creative. So we are going to use an online spinner to do this experiment. So question 7 says, spin the spinner 50 times and record the data using tally marks, then complete the table. Now, we aren't going to use tally marks specifically. We are going to find the total, but if we use tally marks, this video would be really long. So here's our adjustable spinner. I've already adjusted it to make it look like our spinner on our paper. So as you can see, our star space is on the bottom. That's about 45% is what we predicted. The yellow part represents our sun, which is about 25%. And then our smiley, it is about 30%. I don't know why it says 29.9, but it's there. Okay. So now we're going to spin 50 times, and I'm going to show you what this looks like. Just an example. So if I were to spin it one time, just like that, it tells us our experimental and theoretical probability. So this table is pretty cool because it tells us everything that we need to know. We spun it one time, and out of that one time, it landed on the star 100% of the time. And my second spin, It landed on the sun. So the sun and the star now have, a 50% experimental probability. Okay, so I'm going to reset this and we're going to want to spin this 50 times is what this experiment calls for. And if I press spin, it's just going to keep spinning. I don't even have to press anything. So I'm going to let it spin for a couple spins so that you can see what happens. And also notice what's happening to the experimental probability. As it's landing on the star more, right, that experimental probability is going up. Now, like I said, if I sat here and let this spin 50 times, it would be a really long video. So we're going to skip to the end. All right, give me my numbers. What are they? So for our smiley face, it landed 14 times out of 50. So we're going to write that for our smiley. Actually, let me just put all my totals in. Our smiley was 14. All right, go ahead and copy those numbers. For our smiley face, we've got 14 out of 50. And actually, I'm going to go ahead and write that too, where it says probability, because remember, we spun 50 times. So this was a 14 out of 50, 12 out of 50 for our sun, and 24 out of 50 for our star. And if we scroll down, we basically just answered question number 8, but it says calculate the experimental probabilities using your data. So all you're doing is taking these numbers and placing them down here. Now, I want you to do this on your own. However, let's take it up a notch because we are going to be comparing this to what we predicted. I want you to write your numbers as percentages. So turn those fractions into percentages. Take about 2 minutes max. Really should only take about 1, but take about 2 minutes max to do this, answering question number 8. Pause here. So here are our numbers for our experimental probability, or our percentages. And notice how I got those percentages. So I want to draw your attention to my work here. Notice all I did was set up a proportion and I scaled up because I know that 50 is half of 100. I can multiply that by 2 to get 100, and any number out of 100 is going to represent my percentage. So 14 times 2, because what I do at the bottom, I do to the top, gives us 28. So I know this is going to be 28%. And that's just what I did for all of my, back. And that's just what I did for all of my fractions. So I scaled up by 2. And for my sun, I got 24%. And for my star, I got 48%. So those are the numbers that you should have gotten for your experimental probability. Now let's look at this final question. Number 9, it says compare the experimental probabilities with your predictions from question 4. What do you notice and why did this happen? Now, we're not going to answer this together. I want you to answer it on your own or with a partner. Take 2 minutes max to answer this question. And if you need to, of course, refer back to question number 4, absolutely do that. Look at those numbers and compare. So I should see pages flipping. All right, 2 minutes on the clock. Pause here. Alrighty, so here are my comparisons. So our prediction when it came to the sun, we predicted that it would land on that space about 25% of the time. And what actually happened was it landed on it 24% of the time. With the star, we predicted 45%. What actually happened was 48%. With the smiley, we predicted 30%. And what actually happened was 28%. Now, what I noticed are these numbers are really, really close. Are they exact? No, because we answered that question already. There is no way to exactly predict what it's going to land on. But our numbers are really close based on our educated guess / prediction, right? And the second question says, why did this happen? Now, you may have different answers, and honestly, there's no right or wrong answer as to why this happened. It's honestly all left up to chance, and that's probability. All right, that concludes this activity. I will see you in the next video. Awesome job.